Hi everyone, I'm Gutwin, and in this video I'll tell you about a study we did to compare two methods of organizing the items in a visual data set: a traditional paged approach and a spatially stable layout that shows all of the items at once. The reason we did this is because past research has shown that the spatial approach is substantially faster for revisiting items as the user gains experience with the data set, because they can start just remembering where things are instead of having to search for them. And the question that we look at in this paper is whether that still holds when you're working with bigger collections, like this set of 700 items. Now, this looks overwhelming, certainly at first, but our study showed that compared to the traditional paged approach, there are still performance advantages to using a spatial layout like this one, particularly for revisitation. Our work shows that the spatial approach can successfully be used even with big collections, although it's clear that there are also limits to the technique. Here's what I'll cover in the video. First, why it can be difficult to get back to things that you've already found in a visual workspace. Second, how the spatial approach can solve that problem. And third, the study we carried out to see whether paged or spatial approaches are better in a large set of items. So let's begin with large visual data sets. We work with these all the time, whether it's your collection of classic album covers or a set of small multiples in a visualization system, or even the pictures in a folder. There are lots of cases where these data sets can be several hundred items. And the interaction that we're particularly interested in is revisitation, going back to something after you've already found it once. Current systems often make it difficult to get back to things you've seen before because they change the layout of items on the page whenever the user changes things like the filter criteria. Here's an example using a collection from the V&A Museum. The set of objects is organized into 11 pages, and as we look through, we find something that we're interested in right on page 1, the Milton brooch. We continue looking at other things, and at some point, we're going to decide to change the filters. So some of the items don't have images, and so we're going to set the filters to only show records with images. But the system then reflows the items into a new set of pages, and the Milton brooch isn't on the first page anymore where it used to be. And now we have to do a laborious visual search in order to find it again. It's not on page 2, although this one's close. And here it is finally on page 3. Now, this wasn't an impossible problem to overcome, but if you do this a lot in a visual collection, it becomes a real pain. And the problem is worse if you only remember some of the details of the object that you were interested in. What you remember is that it was right there, and now it isn't there anymore. So this is a problem for the filter and flow style of organizing things into pages. And the spatial stable approach, in contrast, doesn't have this problem because the spatial approach puts all of the items on the screen at once and never ever moves them. If something was in the top left when you first looked at it in the spatial approach, it will always be in the top left. And previous research has shown that this stability has substantial benefits for revisiting things that you've seen before. Here's one example, the command maps interface that takes all of the commands from Microsoft Word and puts them all onto the screen and never moves them. Spatial interfaces like this one become faster and faster as people learn the locations, which happens quickly for commonly used commands. So this is great, but the spatial approach has only been tested on small and medium-sized sets of objects. And so we ask the question, does a spatial layout work well for large data sets? So we designed a study to compare the paged approach, like you saw in the demo, with a spatially stable approach that puts everything on the screen at once in a set of 700 items. So let's look at these two interfaces. First, the paged interface. With no filters set, this organizes the 700 items into 30 pages of 24 items each, and the user can go forward and back through the pages or jump to a specific page. Each item shows a picture and a text description with a panel on the right for additional details when you click on one of the items. The user can also set various filters in the left panel to reduce the number of pages that they have to look through. So let's look at the paged interface in action, and it quickly becomes apparent that you want to use the filters to reduce the set as much as possible, because looking through these pages one by one is a slow process. And you can see in the top left that the number of pages is reducing with each of the filters that are set. And now we're down to one page, and it's relatively easy to find the item that we're looking for. Okay, the second interface used a spatial layout, where all 700 items are on the screen at once and nothing ever moves. There's obviously a lot less information about each item, but again you can get details by clicking on one of the thumbnails. You can also use filters with this interface, but instead of reflowing the layout, we show the filter results with highlighting. You can see them here with the green borders. Just as in the other interface, filtering helps the user to reduce the number of items that they need to look through. So here's the spatial interface in action. And you can see how setting the filters is a necessary part of the task. Once you've added some filters, you don't have to inspect very many items in the main view. In the study, participants searched for a set of targets over several blocks, and in different blocks we gave them different amounts of cue information, either full information, or partial with just the picture and a few attributes, or minimal with just the picture. And these are shown on the screen now. The idea here is to simulate different degrees of recollection of the details of the thing that you're searching for. So let's move on to the results. Here's the completion time result. This is how long it took people to get to the correct item. It's organized by block on the x-axis, and the paged interface is shown in red, and the spatial interface is in blue. You can see that in the first blocks, the spatial interface was about 5 seconds slower per item. And we did expect this. It's not easy to find something for the first time in such a large set. But in the last 3 blocks, once people had built up some experience with the targets and where they were located, the spatial interface was significantly faster than paged. In these blocks, we also had minimal cue information, which meant that participants had to depend more on their memory, spatial location memory for the spatial interface, and memory of the object's attributes for the paged interface, and it was clearly more successful to use spatial memory in the spatial interface. We also tracked the number of filters that people used, and here we found a clear difference between the two interfaces. The paged interface in red uses about the same number of filters across all blocks, but with the spatial interface, people used fewer and fewer filters, down to less than 1 by the 5th block. And in the last block, half of the people didn't use any filters at all. This shows that people are developing spatial memory. They're switching from using filters to just remembering where the object is. And that's pretty good when there are 700 items on the screen. We also asked people about their preferences, and the results were split. More people thought that the spatial interface was faster and better allowed them to remember things, but more people preferred the traditional version overall. And these preferences reflect the fact that there were big individual differences in the performance data. Some people did really well with spatial and badly with paged, and some people had the reverse. So there are lots of other results in the paper, but to summarize this brief overview, spatial was slow when finding things for the first time, but faster once the items were learned. People quickly stopped relying on filters with spatial, but filters were critical to the paged interface throughout the blocks, and preferences were divided. So the results of the spatial approach are mixed, but we did give it a pretty tough task. How many of you would have thought that this would have worked as well as it did? With 700 items, we may be reaching the limit of the spatial approach, but our results still show that even with sets of this size, people's amazing spatial abilities can make this a more efficient interaction technique than traditional methods, particularly when people need to revisit some targets more frequently. So, if you'd like to find out more, please see our paper in the GI proceedings or contact us to discuss things further. Thanks for watching.